Good afternoon, everybody. We're going to get started here. My name is Jace Rosso, and I'm the Regional Facades Manager for the Midwest at Wells. Wells is a member company of the sponsors for today's webinar, and I'll be your moderator today. Today's presentation is sponsored by PCI Illinois, Wisconsin, PCI Midwest, and PCI Mountain States. Our goal is to bring a greater awareness of precast concrete to the design and construction communities via quality continuing education programs. Before I turn things over to our presenters, let's review a few housekeeping items. First, you can submit any questions by typing them into the questions pane on your GoToWebinar control panel. You can submit questions at any time, but we won't address questions until the end of the webinar. You can download a PDF of the presentation via the handout section on the GoToWebinar control panel. Don't worry if you can't find it because links to the handout and a recording of the presentation will also be emailed to you after the webinar. Attendees who have fully participated in today's webinar will be issued a certificate of attendance for 1 professional development hour or 1 AIA learning unit with HSW credits. You must be logged in and attend the majority of the presentation to receive a certificate of attendance. A link to the certificate will be emailed to you within 10 business days. If you provided your AIA number when you registered and you attend the majority of the presentation, we will report your attendance to AIA for you. If you're currently viewing this in a group setting where only one person has logged in to GoToWebinar, you will need to email Margaret Mills with the names and contact information for everyone there with you, or she won't be able to send the certificates of attendance. Please remember again to include AIA member numbers if you need your attendance reported to AIA. The course description and learning objectives were listed in the registration process, so I won't take time to read them now, but remember we will answer questions at the end of the presentation. This webinar is broken into 2 case studies. First up will be Jane and Andrea, so let me introduce you to them a little bit more. Jane Chrysler has more than 20 years of experience on more than 200 projects and is devoted to the architectural process, keeping the client's vision and best interests at the forefront. She works with communities and school districts all over Colorado, crafting innovative environments. Her career has focused on important civic buildings, whether it is a new school or a historic structure. She seeks projects that impact entire communities and is passionate in shaping public spaces through the design and preservation of buildings. Andrea Nickel has over 20 years of experience in the architectural industry. Since joining Eidos over 11 years ago, she has been steadfast in creating lasting relationships with her many clients and delivering unwavering attention to her clients. She has experience in K12, liturgical, and retail design, bringing an in-depth understanding of architecture for these building types. So now I'll turn it over to Andrea and Jane to learn a little bit more about the Montbello High School.
Great, thank you, Jace. And thanks everyone for joining. I'm gonna start by talking to you about this Montbello project. You can see the rendering here on the left. And this was a really exciting project that Andrea and I have worked on for almost the last 4 years. So I'm gonna start by giving you a little bit of background.
Jane, you're muted.
That was strange. Thank you, Andrea. As I was saying, I'm not going to read this to you, but what we're going to talk to you about with the Montbello project is how we arrived at the decision to use precast concrete, structural precast concrete, and what went into that decision making and what we felt like were truly the benefits for our project. Huh. Okay, sorry, having a little trouble with the slide changing. Okay, there we go. So the image that you see here on the left is the original Montbello High School that was built in 1980. And you can see that it's very much of its time from the 1980s, kind of your brick bunker type of school where there was still a desire to cut down on natural light and views. which, not what we do today. What I want to point out here is that this building, while constructed in 1980, the community was very passionate about the school. It was very much a community icon. And in 2014, the school, Denver Public Schools, decided to shut down the school because of what they deemed as low performance. And so this was a very painful occurrence for the Montbello community, and they spent the next many years kind of fighting with Denver Public Schools to get their neighborhood school back. And eventually Denver Public Schools agreed that they really should be provided with a neighborhood school in the Montbello community. And so that is what precipitated this project. So in addition to the normal challenges that we see in building a new high school, we had the added complexity of a community and a school district that really had been in disagreement for many years. And so there was quite a bit of community input as part of this process. So here we see an image of the site for Montbello High School. The community was very vocal that they wanted the new school to be on the same site as the original. Really the thing to point out here is that we were working with a very tight site. The green space you see on the bottom of the screen is a community park. So really what we had to work with was what is shown within the yellow lines there. And you can see the school had a few additions over time, which helped kind of fill up the site as it was. Okay, so how did we arrive at using structural precast concrete? So on the right is an image of what our schematic design process resulted in. And to give you a sense, since I said it's almost been 4 years since we've been working on this project, the design team made up of Eidos and EUA was hired in the spring of 2021. The general contractor was brought on board as a CMGC shortly thereafter in the summer of 2021. And since summer, as some of you will know, is not the ideal time to do public input community engagement for schools because people are on vacation, school is out. We spent that summer really kind of digging into this process, assessing the building, because both DPS and the community came into this process saying, maybe we're going to build a whole new building, maybe we're going to do a heavy renovation of the existing building. Let's go through this process and find out what we want to do. And of course, where we landed was somewhere in between. And so we had that community engagement process in the fall of 2021, very active participants, particularly from the alumni group. And then it was shortly after this, once we were able to determine how much of the building was going to be constructed new, how much was going to be retained, that the structural precast fabricator was brought on board in early 2022. And then we, as Andrea will talk to you more about, we met with them weekly. And then our deadline for construction documents was late 2022, and happy to report the building has just received its TCO, and students will be moving in August. So this is an image of one of those first bubble diagrams that we came up with for solving the problem of how are we going to build a new building on an existing site when we need to make sure that all of the students are still able to attend school on that same site for the 2 years during construction. And also, how are we going to incorporate the elements of the building that wanted to be retained? And so here you see an image of our schematic design as compared to the kind of initial bubble diagram. So what I want to talk to you about here is kind of answering that question of where were the students during construction? What did we need to keep to incorporate into the new building? The elements of the building that are shown at the top of the screen that are in that sort of light green and yellow is where we literally cut the building almost in half. And for 2 years, students went to school in that much reduced size high school. It required a lot of renovation. It required temporary utilities and a lot of structural work to, that's the first time I ever had to cut a building in half. The elements that are shown in the blue at the bottom of the screen are the auditorium, the gymnasium, and the pool. Those are the elements that the community wanted to keep from the previous building. So everything there shown in red is what was to be demolished in this first phase. So this is an image of taking a look at again, the blue building elements that are shown, auditorium, pool, and gymnasiums. Those were kept. And this is sort of zooming in on the portion of the new construction, which is shown in red, or the footprint of it, and how we had to stitch or wanted to stitch those building elements together to incorporate into the new construction, as well as developing some new classroom wings as well. So the design process, this is an image here on the left is a rendering of that curved portion of the new building that you can see in the background of it, the auditorium piece kind of sticking up behind it. So what led us to precast? You know, based on what I just laid out as far as the puzzle we had to solve of keeping students on site, having a tight site to start with, but also, you know, wanting to honor this community with a building that looked new, that kind of honored that black and silver school colors that they are very proud of. We started looking at precast, and you know, a lot of times folks will make the decision based on speed or money, but those were elements of our decision. But also in looking at images like this, we really loved how the precast panels looked and the sort of richness and texture that we were able to get with the precast concrete. So this is one of the patterns that we utilized. This is another pattern that we utilized, and again, Andrea is going to get into the details of how this, you know, saved us some time and a little bit of money, but it really also was the fact that there was the permanence, there was a beauty, and the kind of big design idea for this project was this idea of a cultural quilt, in that there's so many different cultures and elements of the Montbello community and opinions, you know, about this project that we kept using this idea of stitching all of these different pieces and parts together to create a more beautiful whole, and we felt like the precast allowed us to do that. This is just a quick image of all of the different building elements and materials that we needed to combine in order to create this new beautiful whole. And again, we felt like the precast panels really supported that. And then the last thing I just wanted to touch on before I hand it over to Andrea is the cost issue, because you know, people always want to know, I always want to know, you know, when you're making these kinds of decisions, how did this help or not help our project? You know, we were fortunate that we had the general contractor on board very early on, so we could analyze the cost of heavy renovation, all new construction, everything in between, but also help us analyze the use of materials. While every project is different, and you know, it's hard to compare apples to apples when you look at, you know, the different elements of the project. The general contractor felt like we saved roughly 2% by electing to go with structural precast panels for the new portions of construction for the building. So with that, I'm going to hand it over to Andrea to get into a little bit more of the construction details.
Great. Hello, everybody. I'm Andrea Nickel, and the key to this precast, at least the successful portion of this, is to coordinate early. I'm going to say often and early. We recommend at least by design development. So we started with a tour of the facility, which was great since it's close by. We needed to understand all the parts and pieces, how it was put together, how it was made, so we could obviously inform the design impact of this. With the tour, we found out that the finish face of the pattern is face down, and we'll talk about the insulation next, and then the inside face that's inside the building is the troweled one that's on the top of that. And as far as the inside of the panel goes, we needed to know what's going on inside of it because, of course, we've got all kinds of things too. We've got the welded wire shown here. On the next slide, you'll start to see some of the conduits, the embed plates, the steel hooks, the pick points. Jane, if you want to flip to the next slide.
Trying. Oops, there it goes.
So there we go. Some of the others. The next slide shows you they are using a plastic form. This is showing you a form liner for, for the brick veneer. And these little thin bricks are just snapped into the plastic form liner and laid down on the bed, and then they pour on top of the brick there, and then the mortar is cast afterwards, which is pretty cool. Moving to the next slide, with coordination obviously comes the BIM model. So we were able to share the BIM model with the general contractor as well as the fabricator had access to it. So they were seeing it the whole time we were out there drawing in it. And again, start as early as DDs at least. This is a whole floor plan. The yellow walls are the precast walls. The blue is the portion that Jane talked about before that are the existing building portions. And with this BIM model, we started these weekly meetings, and they started at the beginning of CDs, and they went on for about 5 months. We were meeting with everybody, and we're pulling in the engineers, so we're having the electrical look at it, as of course structural, but mechanicals in it, plumbing, and every week we're pulling all these parts and pieces together of who's going through the wall, in the wall, etc. The next slide shows when it comes to construction here, Jane talked about how we had a limited site. We couldn't do tilt up, so of course we went to precast, and of course everybody knows school projects are always fast and furious. So we had a phase project, and we did a foundation package first. And the foundation package we did is everything that's showing you here shaded in gray. And by getting all of that in early and poured in place, the precast panels came in and they just set the panels in place, and we've got our building. You can do the precast all the way down to the footer, but this way the foundation was ready to go. If you obviously pull them to the footer, they're part of the foundation package. So this process helped us schedule-wise. So we'll keep moving. And of course, what you need to understand next is kind of the limitations of the plant. So we knew that the truck beds and the pouring beds, they could do 12 feet wide, and our building at the tall points were 48 feet tall. So we knew our panels right there were going to be 12 by 48. You can see the red lines are where we're dividing them up. And then we could start to understand the parts and pieces. Jane talked about the patterns. We have a purpley blue color here that demonstrates where we put the linear pattern. It's kind of drapey looking. And then the cyan color is the rough stone one. The rest is acid etched. And then, oh, and those are, sorry, I had it backwards. Peach was the acid or the sandblasted rough one. and then the cyan is the windows. So once we got all those parts and pieces located, we start to understand that there's cost savings by moving these windows around and moving these patterns around. So don't change the size of them, but just relocate them on the bed when they're pouring this panel. So we're trying to save money that way. The next one is the insert for the window. So this is the part that's the part in the back of the image. The window is being moved around. The images closer are the liners. So then we could reuse those, and that's what's saving us money. On the next slide, this is when it gets kind of muddy, and this is what we're talking about at our weekly meetings. And so we would pull in and start talking to everyone about what all are you putting in the building, through it, etc. We had embeds that we had for steel. We had windows, of course, fire alarm, cameras, of course, lighting's in there, lots of power and data, WAPs, you name it. So we have roof drains that are all of a sudden puncturing the building. And so everybody's drawing on top of these things, and this is happening before submittals. So these are the kinds of things that we were talking about. The next slide, we get into construction. So construction, we started November of 2022 with the panels being poured. So we're already working on foundations out on the site with our first phase that happened. The next slide's going to show you that what Jane was talking about before, limited site, we had the red areas where we had active construction going on. And keep in mind, with the neighborhood around us too, we had 205 semi-truck deliveries coming in with 246 pieces of precast. And we had a crane that had to move around the site 11 times. And everybody sees cranes, but you don't realize this thing weighed 1 million pounds. So that was an effort in itself each time the crane got moved, how we were going to strategically locate these panels and of course not fly over any portion of the existing building where the kids were. So they start pouring these panels, and we could go up to the site and we could review them. And you can see on the drapey kind of linear pattern right here that's showing horizontal, there's some holes in there. And we'll talk about those in a little bit about our sunshades, but we could get a close-up look on the next slide. You'll see we could do quality control of our own there. Of course, Wells had their control, but we can go in and see how we felt about the color that's coming out, etc. The brick on the left-hand side, the thin brick, usually architects don't like the idea of thin brick just because we know it's coming in little pieces like this, but we were able to match the actual full-size brick. So when you're looking at this, you couldn't tell if it was actually a thin brick or a full brick. And the mortar color could change, and we could change it as well, but the mortar was set afterwards on site, which was great. So the deliveries started coming February of 2023. The next slide shows the panels are all up, and this is the coordination thing that the general contractor was saying, schedule-wise, it has a lot to do with. So you can see the diagonals are the shoring poles, and then this is all of our steel inside. And so coordination, this doesn't really save us time in regards to the panels going up fast, but then the contractor is slowly setting all these pieces of steel around the shoring poles. So the schedule kind of times out about the same on this project. Sometimes precast is a lot faster, especially when it comes to the gym pieces. The next slide you're gonna see, so we talked about the foundations package being an early package. So the floors were poured and then the stem walls. So then these panels came in and they were set. And we've got these little pockets, the arrows pointing to them right now. These are the weld pockets. And if you go to the next slide, you'll see a close-up of them. The one on the left is looking at the end of the panel before they set it on the ground. The one on the right is the weld pocket. So the foundation wall sticking up with these little embeds, and then the steel is, you can see where it's slotting into place with the precast. And these embed pockets, weld pockets, get fully grouted out and painted over. But you'll see this in the finished product unless you are framing over the wall. So something to keep in mind. The next one we're talking about is continuous insulation. So these white panels you see over on the left are CFRPs. That's carbon fiber reinforced polymer grids that the black portion is on. And it has a 1/2 inch embed into the concrete panel on both sides, which makes this a structurally composite panel. So we're getting continuous insulation around this whole thing. We don't have to worry about it being conductive, and it's not corrosive as well. So this is one of the huge advantages with precast. The next slide, moving out to the exterior of the panel, I told you about those little holes that were in one of the bigger panels. We were using these to attach our sun louver supports to. These are little pieces of steel that are attaching to the precast. Well, we couldn't, I should say cast these into the bed. So if you go to the next slide, Jane, we used you can see the detail here, and then click it in again, Jane, and the little loop's gonna show up. Maybe. Okay, there it is. So you're seeing a detail of the precast concrete with a steel angle in it. And then this little piece that popped up at the bottom is called a straight loop ferrule insert. That was cast into it. It was cast. And it didn't go through the insulation because we couldn't ruin our continuous insulation. We had to make sure we were thermal. And we didn't want to compromise the integrity of the panel thermally or structurally. So by utilizing this little insert, then we could bolt our steel angle attachment onto for the sunshade louver. So the next slide shows you the end result. It's a close-up of what this looks like. So we have our wood louvers here, and then there's 4 loops on either angle, on either side. So the next slide, so we talk about those holes. Well, unfortunately, before we could get to it and it was poured, we had a whole row of these sun louvers on the very bottom elevation, which we removed after it was poured. But the great thing with precast was they patched all these holes in place while it was up, the panel was up, and you can't even tell. So if we even zoomed in on site to the bottom of this elevation, it's undistinguishable, which was great. So now let's look inside. This is the inside of the new Ox Gym, and these are precast walls, which we have just painted over. They look like they just kind of have a troweled finish. Some of areas get a little bit more bumpy in a way, but this shows you all the coordination with regards to the scoreboard, the mat hoist, the anchors, the electrical, everything that's buried inside the precast. As I like to say, speak now during coordination or forever love your exposed conduit, because that's what happens later. So let's zoom in a little on the next slide. A couple other things to consider is, what is this precast going to look like when at the end of it or when we're cutting into it? So those window inserts you're seeing on the right over here. So we put in the window, the precast is on the left, we have a solid surface window sill. We painted the precast, but there was a gap between the precast and the window. So we ended up putting a little piece of brake metal here to fill that gap and then caulk it. The image over on the left-hand side is the end of one of these panels but it's showing where it's attaching to the embed on the foundation. So you have to remember to think about these things on all three sides sometimes, not all the time, but they did end up putting a little parge coat over this and covering it up so it blends in and looks like the finished acid etched wall. Moving into the building a little bit more on the next slide, we're inside one of the classroom spaces. So the far left, are two precast walls, because this is the end classroom with some windows, and they painted the walls, and we had quite a few rough spots. And they could come back in, they can smooth them out, and they can paint over these. The right image is the finished product, but I have a couple arrows on here because I want you to be aware there are some really big caulk joints. So I would say the caulk joints are easily an inch thick throughout. So we put all of our technology over on the left-hand wall here. Of course, you can fur these out, the precast walls, but to save money, we left these exposed. But just keep in mind what you're gonna get. The next slide's a video, and this is them setting the panels, and it times from February of 2023 to April of 2023. So just a couple months, it shows you how fast these go up. We'll see. It's a little jerky. So, and that is the end of our Montbello High School presentation. I will turn it over to our next presenters, and then we'll take questions at the end. So thanks for listening so far.
All right, thank you, Jane and Andrea. So next is going to be Charlotte and Jacob from ISG. Charlotte Nienhaus is an architect who brings expertise and focused passion to her projects. Having been with ISG for over 8 years now, she primarily does work in the K-12 educational market, but has experience in commercial, multifamily, and various other project types. She is passionate about elevating learning environments and working with rural school districts to create designs for their entire community. Jacob Sonic has 10 years of experience working on more than 60 K-12 educational facilities around the Midwest. He approaches each project analytically and focuses his education designs on enhancing safety, durability, and longevity for each district. Jacob aims to understand the goals of each project to provide solutions that maintain and encourage the well-being of students, staff, and the community. So now I'll turn it over to those two to teach us a little bit more about the Maple River K-12 school.
Thanks, Jace.
Charlotte and I will be presenting a case study on Maple River School's new K-12 building. The purpose of this case study is to illustrate the efficiency, cost effectiveness, and durability of a total precast solution. Some background on this project: Maple River Schools is located in south central Minnesota, consisting of 4 rural cities: Mapleton, Minnesota Lake, Amboy, and Good Thunder, which consolidated in 1992 to become Maple River. This school district's enrollment, K through 12, is approximately 900 students. Before this project, Maple River had elementary schools in Good Thunder and Minnesota Lake, and a middle and high school located in Mapleton. Upkeep with these various aging schools and transfer of students to multiple locations kept operating costs high for the district. This project, from the onset, had a very aggressive timeline for the design and construction. That, combined with this project's proximity to wells, made precast a very attractive option from the start.
So yeah, a little bit more into that project background. So like Jake said, the operational expenses of maintaining those 3 buildings was really a massive driver. All of their buildings were also aging, ranging from 1930s and then various additions all the way up to the 1970s. The buildings were in poor shape. And Amboy, the middle school, has already been taken offline, and they had declining enrollment. That was also contributing to those operations issues. To get this project passed, it took 3 failed referendums. The 4th passed, largely, I think, in credit to the passage and increase of the egg to school credit tax credit in Minnesota, which was passed in 2017 and raised to 70% in 2019, just before the final referendum, which raised a 70% tax credit back on agricultural land to districts that qualified. So that was a major contributor to getting their bond passed in February of 2020. The goal was to consolidate those 2 elementaries, 1 middle school, high school, into 1 preschool through K building on 1 site. All of the other buildings would be either decommissioned or demolished, which they're still in the process of. I think one of them is maybe in the hands of a city now, but all the other ones have been taken down. So with that, the school was completed and opened on September 2022. So we had just a little over 2 years for a design and construction process. And we're happy to say that from that, enrollment has now increased through that process by about 75 students. So a little bit more into our design and construction timeline here. The fun thing about Maple River was we had COVID thrown in there. And so we like to show what our planned design timeline was and what the actual became. We had 1 meeting with the district on March 3rd, and then we're sent home on March 15th. And so everything that we did had to be turned into a take-home packet of sorts. And so we created a lot of materials that we could send to planning groups within the community that they could do at home, send them back to us and gain their feedback. And we are, I should say, throughout this entire process, because of the strong relationships with Wells, there were multiple students at Maple River whose parents worked at Wells, multiple alumni who worked at Wells. From day one, we knew precast, a total precast solution was the way we were going, from district leadership telling us that's what they wanted to do, but also the schedule. And so that was something that we knew in working with community groups that we were going to be doing. And so we're happy to say from this timeline, we actually were able to submit construction documents about 2 months earlier than we had planned for, even with COVID, doing its best to ruin that, I guess I should say. And so meeting in person with people was problematic, but we found a way to get input there. A little bit into the design process. So this is just some iterations of how we had worked through the floor plan. I wanted to touch on in that we tried to economize and work with specific precast elements in planning out the sizes of all of the spaces, knowing that, not only were the walls a precast sandwich panel, but also we were using hollow core and double T's. And so trying to coordinate everything with the span of those elements for the floor and roof as well, which Jake will touch on a lot more in depth here. But so that really was a driver on certain spaces that we knew we were repeating over and over again, like classrooms. And so we've sized classrooms actually to work with a common hollow core width, so that we weren't cutting things down on site. We could use more standard widths and depths as needed, and really have an efficient floor plan from the get-go that worked with that. This is just a quick shot of what we ended up with for a site plan, a rendering. And so just to show you, we had about 60 acres to work with, which was about 30 acres too small, I would say, of what's recommended. And there's also an existing farm site that didn't really want to sell on this site. And so that cut into the site at the top left there where we have all the text over it. And so the other driver also was that we had to balance using the site effectively, getting all of these elements on the site. It seemed like every day they were asking us to put more on the site. And so there was a lot of stress on it on that. But also, how do we efficiently use precast, but get lighting, natural views to every single room? And one of the things that I'm really proud of is there's only 2 classrooms within this 200,000 square foot facility that don't have exterior windows or views. And so I think we were able to really use the precast well in an economical way, but also get every classroom what it needed in terms of natural light views. So this is just a quick overview of the floor plans. Again, one of the things that the district really wanted here was like a college campus setup and feel. They wanted open spaces, natural lighting was a huge player in this, and we'll have some finished photos at the end here to show how I think we achieved that. But I just wanted to highlight here that there's a lot of spaces within this building that are open to each other, and precast definitely contributed to that. Precast being inherently almost non-combustible allowed us to use a certain code type. It was type 1B, which is unlimited in terms of the allowable area you can have until you need a fire separation. So there are actually no fire separations in this building other than the storm shelter, which is on the first floor in purple. And we'll talk more about that as well. Otherwise, there was no need for any fire separations. And as we know in design, those things can be nasty to deal with. Firewalls are very complicated. And so that really, helped us, I think, design this a lot quicker, but we were able to open up the commons, the gym, all of these breakout spaces, the media centers. There's so many places within this building that are open between floors or other spaces that I think really give it a very unique and cool design overall.
Utilizing the total precast building with exterior precast panels, interior precast column and beam lines, precast spandrels, hollow core plank floors, and our double T roofs provided a multitude of benefits. The only steel that we have on the project is the roof deck and roof joists for the auditorium and the varsity and middle school gyms. With that, and as Charlotte had said, with this being a type 1B construction, those structures were actually high enough that no fireproofing was needed on those structures and that structure either. In addition, working with a complete precast structure made utilizing our elementary gym for the 1,100 occupant storm shelter easier and more streamlined. Allowing the precaster to set all the structure and continue on without a break in the schedule was a huge benefit. Within this project, also different areas were designed for future expansion on the second floor. Because we're utilizing the hollow core plank for our standard floor system, we're able to use that as a roof system and keep all the structural requirements for future expansion to change to a classroom. These additions are actually in the works now. As we had said earlier, the enrollment has been growing rapidly. Overall, the biggest benefit in the total precast we saw was in the planning stages and schedule. For a building of this size, almost 200,000 square feet, going with total precast allowed us to greatly shorten the overall timeline of the project. From the first precast wall panel set to the last double T roof member was only about 60 working days. And at this point, the building was almost fully enclosed, allowing all of the trades to hit the ground running, not waiting on other components like we have with the different building types. Coordination between ISG and Wells played a pivotal role in the project being successful. We were also able to bring Wells on early through an early bid package to help with building efficiencies, timeline requirements, and any concerns that they see. This early contract allowed us to proceed with finishing our architectural, mechanical, and electrical drawings while Wells built their model. Isometrics of the Wells' model are shown on the side here, which were used to help produce the shop drawings. With weekly model updates and bi-weekly meetings between ISG and Wells, we were able to streamline our shop drawing process and also greatly reduce our issues in field with openings such as windows, doors, wall changes, or all mechanical openings throughout the building. Being able to keep up in real time as opposed to waiting for the CD drawings was vital in us getting precast out on site. Lastly, a large obstacle for Maple River Schools was that this was the first constructed ICC 500 storm shelter in a school after the state of Minnesota adopted the IBC 2018, which now requires storm shelters for all educational buildings that add more than 50 occupants due to the wind loadings in our area. It was a learning curve not only for ISG and Wells, but also for the state of Minnesota. ISG, Wells, and the state met multiple times to ensure that the design and interpretation of the ICC 500 was clear. The inclusion of precast allowed us all to meet the stringent requirements while also keeping the cost down. And now, multiple school constructions later, the state still recommends precast for storm shelter design due to the efficiency compared to the alternative options. This coordination throughout the project helped make this facility efficient for Wells, which in turn helped the project come in millions of dollars under cost estimates.
So let's get into the finishes just a little bit. Since we knew we were working with precast, we also wanted to make sure budget-wise we were being cognizant of that. And so we really used metal panel to highlight the precast on this building, but we wanted the precast to stand on its own in terms of finishes. And so you'll see there just some photos of the different finishes. We used a white precast and a gray precast. The white was chosen mostly because the district wanted to stand out. They said, we don't want to look like a lot of other buildings that are precast, and white, I think, is becoming more popular, but in this area, at least, and what they had seen a lot of, it wasn't as popular, so they liked that. And then we used the gray for the majority of it because they're also a little worried about looking too flashy and being too busy. And so we had to balance both of those, of how do you stand out, but also not go overboard. And so we also used a brick to inlay to highlight at certain areas. You can see it kind of over towards the left. It blends in fairly well. Overall, we had, I think, 8 different precast finishes. We used a polished precast on the interior because we thought if you need something durable inside where your, let's say your cafeteria is, why not just let the precast do that? We had to play scientist and show the school that the precast would hold up to their cleaning chemicals, which I don't think Wells had any concerns about, but we still left a panel sample in a bucket of a cleaning chemical for about a month, and that was enough to show them that I think it'll hold up if it can sit in it for that long. So that was kind of a fun part of the process. Throughout this, we had 11 different unique panel types, but again, across 200,000 square feet. I think we did a pretty good job of giving them variety, giving this something that's going to, look good, but also that economy there. And so 11 across the 200,000 square feet, I think was pretty manageable. Throughout design, the district and the staff were very interested in learning about it. And so we actually did a staff day. I know one of the Wells employees lives right by the site and would tell us, well, he's keeping an eye on it, and would always talk to us about how cool it was getting to watch all that go up. And so we took about 100 staff on site as well and walked them through the building when it was under construction, and they were pretty excited about that. We also went out and toured Wells's plant while Maple River was under production, got to see them polishing some of the panels, just gave us a better understanding too for future projects of how can we design these finishes on these panels to work well, not only in the plant fabrication, but then also look really good. Where is that balance? I think throughout this entire project, we wanted to make sure we worked with precast, but we also kind of forced precast to work with us in certain ways. And so there was a lot of areas where I think we pushed some limits of spandrel panels, opening sizes, those sorts of things to kind of get what we wanted in a design, and then also made sure to meet in the middle and work with what's the most efficient for precast as well. Just a couple more photos here.
Yeah, I think these pictures really showcase the opportunities that precast allowed us during construction. The picture on the left, we were able to leave out 2 of the precast panels in the main gym that allowed truck access into the building and storage and accessibility for all the other trades. The second picture on the right highlights the openness of our first floor. Utilizing the precast column and beam lines, along with hollow core plank, kept our floor framing depth down. The total system is about 16 inches, including the topping, which in turn kept our floor to floor heights down. This picture is also taken less than 60 days after we went vertical with construction, and the building is completely enclosed.
Here are a few finished photos. So these are some of the things we were touching on. We have a grand staircase and the upper level, which we have another photo of, into the gym. We wanted to touch on the auditorium, how precast lended to that.
Yeah, utilizing the precast spandrel over the proscenium opening allowed us to support our roof and all the rigging equipment that we had without the need for columns on each side that butt into the space.
Just a couple more photos of the gymnasium at Maple River. One of the big highlights to them was they kept asking us, how do we make this cool? We want our gym to be unique in terms of the competing area schools. So one of the ways we did that, we have kind of termed it the Eagle's Nest. is this upper level balcony. And, you know, usually gyms are so large that they end up being a separate fire separated area in themselves. But because we didn't have to do that at all, we could open it up on 2 different sides because of that precast, really. Couple more photos again of just some of the breakout areas that you saw under construction. So that column line, we really think the columns just kind of fade away. You can't even tell they're there. One of the things we also did was we furred out every single wall in the classrooms. So interior wise, inside the classrooms, there is no exposed precast. 2 reasons for that. We felt just a finish that we wanted there, but also then the ease and flexibility of any sort of future updates for tech or electrical. They could do that on any wall then inside of there, and just kind of one less thing that we had to plan early on for the precast. But yeah, just some finished photos there. The one on the bottom right is the media center, which is also open to a walkway and the first floor sort of thing in their cafeteria. So with that, that was all we had on Maple River. I think we'll turn it over for questions on both Montbello and Maple River, and thanks for letting us talk a little bit on that.
Yes, thank you, Charlotte and Jake. Just a reminder here, you can still submit questions in the questions pane, and we'll kind of get started on those. First of all, for Jane and Andrea talking about the Montbello High School there's a few questions that came in about the overall delivery process of this. Was this considered a design build project, or how was that all, you know, finalized, and when were the contractors and the subcontractors brought on board throughout your design process?
So it was not, this is Jane, it was not design build. The design team was hired initially directly to the school district, and then the general contractor was brought on just a couple months later and hired directly by the school district. They did bring their subs on very early. So, you know, while it was not a design build project, you know, we did go through and prepare the construction documents, but with input from the general contractor, which was really key. And in addition, having their subs on board early was key.
Okay.
Andrea, I don't know if you wanted to add to that. Or go ahead, Chase.
I was just going to say a quick follow-up. You know, I know in some regions that's difficult to do at times. So was there any roadblocks, you know, to having the subcontractors brought on early? And then also, you know, what were the overall benefits that it provided you?
We talked about this during the presentation, that we recommend you bring in and start the coordination at least by DDs, because then you're starting to talk about what all is penetrating this system with mechanical and plumbing, how tall these are, how wide they are, because that informs your structural grid and as well as the foundation. So as early as possible, but no roadblocks really on this one.
Yeah, I would say the only kind of leap of faith was that this was during design, was still when supply chain issues were happening and very long lead times. So we had to go ahead and make some decisions, and the general contractor was able to place orders for equipment and other items, you know, prior to the full design being completed. So there were some blurry lines as far as if you know, we're calling this a design, you know, CMGC or design build, but we didn't have any hangups with the client.
Okay. And were there any carbon credits or other environmental limitations with utilizing the precast system?
No, not that we took credit for, but I think you can get them.
Okay. All right. And then on the Charlotte and Jake, One question came in, was there any third-party QC inspections at the precast plant that were required for the project?
I don't believe so. There were additional inspections that are required for the storm shelter, but they can be done by, they just need to be done by not the signing individual on the project. Saying that right, Jake?
Yeah, that's part of the ICC 500. The storm shelter has to be QA/QC reviewed by somebody that isn't involved in the project, as another structural engineer.
Okay. And Jake, when you were kind of talking about the future expansion that you kept in mind with using hollow core at some of the roof areas that would be future expansion for classrooms, one question was, why did you guys choose to use hollow core in these locations and not double T's? And then also kind of overall, why was hollow core used at the second level instead of double T's?
Hollow core was beneficial for us because of the depth of the system. We were able to use 12-inch hollow core with 4-inch topping. If we were to go to double T's, we're a little bit deeper and causes issues with mechanical, increases our floor-to-floor heights, things like that. So, and then the areas where we were 2-story that went down to 1, the reason why we left that as a hollow core system was to make sure we weren't stepping ceiling heights or anything like that below that on our original construction. So trying to keep everything consistent throughout the building, whether it had a second story above it or not.
And then we did use double T at the roof.
Yes, double T for the roof systems, just allowing a little bit longer spans there.
Okay. And in Maple River, there was, all these large open spaces. Was there any issues with sound and echoing that you guys had to address?
I will say, one of the cool things walking through it when it was like just precast under construction, I think precast does a pretty good job of absorbing some of that sound more than we might think. There was a lot of times when I'd walk through and contractors would have, massive boom boxes playing, and you'd walk into the next room and you wouldn't hear it at all. But within certain areas, we did add, acoustic deck in the gyms and a lot of acoustic panels on the walls around those gym spaces to address like echoing. But within actual classroom or media center, even just the carpet, and then we had some baffles in the ceiling was enough to address a lot of the hard surfaces that were there.
Okay. And this question is for both design teams here, but I'll start with Maple River since we're on it. The project's using cast-in thin brick. What were the design details at window openings or door openings? Did you return the brick or leave them flat?
On this one, with the cast-in brick, we did not return the brick back to the window openings. And I know we could have, and I won't say there was really that much of it was kind of one of those of like, well, we could do it either way. And when we talked with the owner, they kind of liked that, no, this is precast and it's going to look like precast. And I think we had done a stack bond as well. And it was just different in different ways. And so we chose to just not return the brick back and just have a precast finish inside of that jam.
Okay. Jane and Andrea, what was the design detail on Montbello?
We tried to focus the brick on the areas that didn't have as many openings, so it wouldn't have to return, because then it's, it's just a little trickier. But where we did punch it, there are pieces that you can put in there that it does return.
Okay. And the last question that I have here, I think Charlotte, you mentioned in your presentation that it was a different construction type for Maple River. Could you just repeat what that was again?
Yeah, so I think a lot of times, and I'll just say this on our experience, we work with a construction type of 2B, which is, usually then your exterior walls don't have to be rated or, non-combustible. If you're working with steel, that lends to it very nicely, but then you are limited to certain allowable areas based on the use of the space, that sort of thing. And so because all of our bearing walls and anything that was bearing for roof and floor was non-combustible, or we could prove that it met, you know, a 2-hour rating pretty easily. We were able to use type 1B, which then off the top of my head, I just know your bearing walls and roof and floor have to meet a certain rating, but then you are unlimited in terms of allowable areas. And so we didn't have any firewalls anywhere, but we could, you know, obviously prove through testing and data that the precast for certain thicknesses of the hollow core and double T's met that required rating.
All right. Well, that wraps up the questions here. So thank you again to the presenters, and thank you everyone for attending today's webinar. You should receive an email with a link to your certificate of attendance within 10 business days. And thanks again for joining us. Have a great day.